We all flush, shower, and wash dishes, do laundry, but where does that water go? Let's take a virtual journey and uncover the hidden world beneath our feet. It might not be the most glamorous, but it's definitely a crucial topic, our wastewater management system. But before we get into the nitty-gritty details, don't forget to hit that subscribe button and give this video a thumbs up if you're excited to learn something new today. Now let's get started. Now let's understand what wastewater actually is. Wastewater is any water that has been used and discarded from our homes, businesses, industries, or agriculture and is no longer needed. It includes water from our toilets, sinks, showers, etc. Basically, this includes everything from household sewage to industrial waste. Now imagine all that wastewater flowing through a complex system. That's where the wastewater management system comes into play. It's like a giant recycling center for water. It is also called sewer treatment plant. But instead of turning it into something new, it's all about cleaning it up so it can be safely returned to the environment. And we have to manage our waste because it stinks, it contains deadly bacteria, and it has dangerous chemicals that could affect the environment. So let's break down how this system works, starting with the collection phase. When you flush the toilet or wash dishes, the wastewater travels through a network of pipes underground called sewer lines, like tiny underground highways. These pipes carry the wastewater to a treatment plant. But wait, there's more. Along the way, smaller pipes called lateral lines collect wastewater from homes and businesses and feed it into the main sewer lines. In every main sewer line, there are these vertical pipes that go down to the ground and have manholes on top. These manholes are spaced out according to local rules and are there just in case something goes wrong in the sewer pipe. For example, if your kid keeps flushing toys down the toilet, they might end up in the main sewer pipe and cause a big blockage. Then, workers from the city have to come and fix it. This system is connected to our wastewater treatment plants. Wastewater moves through the sewer pipes by way of gravity and pump stations. Usually, these sewage treatment plants are built in low-lying areas because it makes it easier for engineers to design the sewer systems. But this talk about gravity-fed sewer systems is assuming everything is perfect. What if your house is lower than the sewage treatment plant, or if the sewage has to go over a hill? In those cases, you need to pump the sewage up. This is done using special pumps called grinder pumps, or lift stations that push the sewage up and over hills to reach the treatment plant. Now let's talk about what happens at the treatment plant. Once the wastewater arrives, it goes through several stages of treatment to remove impurities and harmful contaminants. The treatment process typically consists of 4 stages: screening, primary treatment, secondary treatment, and tertiary treatment. Each stage targets specific pollutants and contaminants, ensuring that the treated water meets environmental standards before it's discharged back into the environment. First up is the screening process, where large objects like sticks, trash, and debris, baby toys, earbuds are removed from wastewater to prevent damage to the equipment downstream. Next up is the primary treatment, where the wastewater is held in settling tanks. Here, heavy solids, made up of poo and toilet tissues, settle to the bottom, forming sludge, while oils and grease float to the surface, where they can be skimmed off. Even the heavy solids excluded here are further processed separately in gravity thickener tank to produce biogas to generate heat and electricity, and remaining sludge at the bottom can be used to make compost for gardening for consumers. The secondary treatment is where the magic really happens. Microorganisms, beneficial bacteria, are introduced to the wastewater to break down organic matter and pollutants, converting them into harmless byproducts like carbon dioxide and water. But we're not done yet. Some treatment plants also have a tertiary treatment stage, which uses advanced filtration and disinfection techniques like UV light, ozone, or chemical processes like adding chlorine to remove any remaining contaminants. Once the wastewater has been thoroughly treated and after meeting strict quality standards, it's either returned to rivers, lakes, oceans, or reused for purposes like irrigation or industrial processes. There are 3 main types of wastewater: domestic, industrial, and agricultural. Each type comes with its own set of contaminants, from organic matter and chemicals to pathogens and nutrients. Domestic wastewater is generated from households, including water from toilets, sinks, showers, baths, and washing machines. It contains organic matter, such as food scraps and human waste, pathogens, bacteria, viruses, etc., detergents, oils, and other household chemicals, and is typically treated at municipal sewage treatment plants, where it undergoes physical, biological, and chemical processes to remove contaminants before discharge or reuse. In rural or remote areas where municipal sewage systems are not available, on-site systems such as septic tanks are used. These systems treat wastewater on the property where it is generated, typically through a combination of settling and biological processes before it is released into the soil. Industrial wastewater is produced by industrial processes in manufacturing, mining, power generation, and other industries. It is highly variable depending on the industry, but may include heavy metals, toxic chemicals, oils, solvents, organic compounds, and high levels of nutrients, or pH. Industrial wastewater is treated in on-site treatment facilities or municipal treatment plants using specialized processes tailored to the specific contaminants present. Treatment may involve physical separation, chemical treatment, biological degradation, or advanced technologies like membrane filtration or reverse osmosis. Agricultural wastewater arises from agricultural activities such as irrigation, livestock farming, crop production, and agricultural runoff. It contains nutrients, nitrogen, phosphorus, potassium, pesticides, herbicides, sediment, animal waste, and organic matter. Agricultural wastewater management involves practices to minimize runoff and pollution, such as implementing erosion control measures, nutrient management strategies, and utilizing constructed wetlands or vegetative buffers to filter and treat runoff before it enters water bodies. Proper wastewater management is crucial for protecting the environment. Without treatment, wastewater can contaminate rivers, lakes, and oceans, harming aquatic life and posing risks to human health. Despite its importance, wastewater management faces challenges like aging infrastructure and increasing urbanization. However, innovative solutions such as decentralized treatment systems and water reuse initiatives are being implemented to address these issues. It's essential for all of us to understand the importance of responsible water usage and wastewater management. By being mindful of what we flush down the drain and supporting initiatives to improve sewer systems, we can contribute to a healthier environment for future generations. And that's a wrap for today's video. I hope you found this explanation of wastewater management systems helpful, and I'll see you in the next one.